Okay. So we're going to have the exam one review. Wait, that's not right. What are we doing? We have nothing due on Wednesday. Wow.
I have a question.
Yes.
On my BB Learn, I'm not too sure about others, but it actually says that we have homework 6 that's due on Wednesday.
Yeah, the assignment says it's due on Wednesday, but I think the due date in BB Learn has been changed to Monday. I'm giving you an extra day for it. Kind of what has changed is we have enough people taking the exam in Zoom that we should only have about 20 people in here in person taking the exam. So this classroom holds 60, so we can easily fit 20 people in here and still meet COVID rules. In fact,
Sorry, so this is the new updated schedule, so we're no longer
Yes.
breaking it up into 2 sections? Okay.
I'm not breaking it up into 2 sections. I just moved everybody back to Wednesday. And the good thing about that is it gives me 2 days to cover circuits in the S domain, which I think is a lot more reasonable. And that also means that the homework got pushed back till Monday. The assignment page still says Wednesday, but all the due dates in BB Learn say Monday. Okay. And it gives me an extra day to do this. So I'm not flying through this quite as much as I normally am, which I like. What is pseudo spring break? No pre-lecture quizzes, no homework due. I may give you an exam. I'm thinking about that. No labs. We'll meet for class, so I'm gonna have more time for electronics. Having a third exam in here, I think will be helpful for you guys because it's not as much material to study for one exam. So I'm thinking about it. Normally, on a normal semester where everything's running correctly, I'd normally have 4 exams in here. I have an IEEE meeting tonight at 5:30 p.m. in the cave, or we'll probably move over into whichever one's empty, EGR 234 or 235. Watch the movie on the projector and project it through Zoom. We'll just use my Zoom link, and then everybody can find that. And then we'll figure out what we're gonna do next. That'd be a good thing too. Maybe we can talk about that. NAU does have an accelerated master's program. There's a lot more variety and job opportunities you can get between graduating with a BS and an MS. If you graduate with a BS degree in electrical engineering, you're pretty much going to start out as a test engineer or an app engineer, unless you're extremely talented. If you have a master's degree, a lot more job opportunities open up for you, and you actually have a higher starting salary and generally are given a higher starting position. It's like having they treat it, it takes 1.5 years, 2 years, and they treat it like you have 2 years experience. 6 credit hours from your bachelor's degree will count for both your bachelor's degree and your master's degree. So you get to double dip a little bit. A good GPA is necessary. I don't know where the line is this year, and no GRE is required. You can see your advisor for details, or if you know who Slava is, just contact him directly. Nobody knows what his last name is, and that Slava's not his real first name. It's Vicious Slava Kola to what? Yeah, something like that. So we just call him Slava. Oh, Lauren, yes.
Would you be able to email his like his email to us, or maybe his Facebook page?
Yeah, just send me an email and I'll look it up.
Right.
I know it begins with a V.
Cool. All right. Thanks.
He's a really nice guy, and he's easy to talk to, and he loves to get people in the master's program because that's his whole job, is getting more students in.
Sounds good.
Okay. This is from Tyler Lee. He was a senior the first year I started here. He graduated, and that was 2012, and he graduated. We were still like going through that 2008 recession thing, and not a whole bunch of people were hiring. He had a great GPA, like 3.87, something like that, but he never worked a day in his life. And when he got out, he couldn't find a job. And he ended up substitute teaching in Las Vegas for a while. And then he got really depressed and then found the job after about a year and a half of this. He found the job at General Dynamics. And so he used to come and really depress my students, come talk to IEEE meetings. But he's got a great job now. And he loves it. What you're doing now as a sophomore determines what you have to put on your resume next year when people start hiring. Some companies will hire for interns do your freshman year. Some sophomore year, the brunt of them, it's after your junior year. But you want to have something to put on your resume to get them to hire you. Skills. We'll have a resume workshop in IEEE. We'll talk about that. You want to put your skills up top, education and then skills. You must be able to answer questions about what you individually did to contribute to projects, and that's both classwork and outside of class. Do you have a hobby where you build little Arduino circuits for fun? One guy had a hobby where he built this whole microprocessor controlled hydroponic strawberry growing factory down in Prescott. His family had a farm down there. Really amazing. And we kept the, water, the soil moisture goes below this point, you get watered automatically. He didn't even have to think about it. Research jobs, and it doesn't even have to be anything elaborate, just something that shows that you have initiative. Internships, lab TA jobs, they look pretty highly on. And your engineering recruiter generally does not care about your job at Pizza Hut. I've seen people's resumes and they will have a whole page full of, well, I worked at Pizza Hut for 2 years. And then before that, I worked at McDonald's. And before that, it's a whole page of this. No, you've lumped that all into one little subcategory and say, work my way through school. They don't care about the details of that, or with good customer service skills. Things like that, and we'll have a resume workshop eventually once we get a little bit more people coming in, or we can do resume workshops over Zoom. So these Bodhi plots, this is like the key slide for this, and this is what I looked at when I had to plot these first couple of years I taught it. We have the 7 factors. We divide our terms up into a group, into the groups of the factors. It's convenient for me when I was first doing this to name them and say, okay, here's my constant, my value of my constant. I have a 0 at the origin. I have a simple 0 at some frequency, and write those down. Then use this chart to plot the individual factors. And once you do that, you add them all together. Needless to say, I really have developed a method for grading Bodhi plots on the exam. And it doesn't take me nearly as long as it used to. I stopped. It's like, did you do the work? Are some of your factors, this is the question list that goes through my head. Are some of your factors okay? Is your overall response okay? If the overall response is okay, it's full credit. And then the rest of it, I look for pieces that I can give you points for. Something on there that's right. You can do these Bodhi plots in MATLAB, and it's a good way to check your homework, and you'll get to do this in the lab, starting with lab 4. You'll have to make Bodhi plots in MATLAB, compare them to the Bodhi plots from Multisim, compare them to your hand-drawn Bodhi plots. Lots of math in the 280 lab. Okay, circuit analysis in the S domain. Believe it or not, all this math we've been talking about has applications. It seems pointless and seems like I'm going through a whole bunch of disjointed mathematics. I started out talking about switching circuits, okay? And then I went into the Laplace transforms, and then these Bodhi plot things, and there doesn't seem like anything's connected yet. And this is my last set of slides before I get to talk about electronics. We just move on to another course. I did not make up the syllabus for this course. Okay, we had this circuit a couple of sets of slides ago. We looked at it and realized we had no clue how to solve it. Now you have all the techniques that you need to solve it. Basically, what we have to do is we're not going to do it yet. I don't think I do it yet, so I don't want to get too far into this. I think this is towards the end of class. We can ignore U of t because we know we're going to put this in the Laplace domain. We can take the Laplace transform of this, s plus 1. We can take the Laplace transform of 2 delta t. It is just 2. We leave our resistors alone. The only thing we don't know what to do with yet is this capacitor. We know we can put that in the frequency domain. It's 1 over SC. But there's another little glitch to this that we're going to talk about as soon as I reboot my computer.